A pleasant day to you all, especially to Mr. Coliantes. So in this video, I'll be doing our performance task 4.3 under the subject basic calculus. So first things first, I'll introduce myself. So I am Joe Mary A. Panad of grade 11 STEM 12A. So in this video, we'll be filming ourselves or having a video tutorial regarding the optimization problem, or otherwise it is called the maxima or minima. So we were asked to find a problem by ourselves, and our group leader happened to find it and decide and assign to each one of us. So the problem I got here is, what is the maximum area of a rectangle with a perimeter of 200 feet? So hello once again. The problem I have here with me is to find the maximum area of a rectangular shape with a perimeter of 200 feet. So I have here a rectangular shape rather. Let's assume that this has a perimeter of 200 feet. So the first thing to do is to label each side, the y and the x's. So as you can see, it is already labeled. And before we are going to proceed, let's write down the perimeter, the formula of the perimeter. So as you can see, it is already written down there. The p is equals to y plus x plus y plus x. So then the next thing is to write the p is equals to 2y plus 2x, since there are 2 y's and 2 x's. And as you can see, the 200 feet, this is where we put it, and the 200 is, we get the 200 from the 200 feet. So 200 equals to 2y plus 2x, isolate, so it becomes to 2y plus 2x and minus negative 2x and negative 2x. So the thing happened right after is that this must be cancelled out like that. So the next thing after that is to the 200 is minus the 2x over 2. We put the 200 and we put the minus 2x above, and they interchange with the 2y. So 200 minus 2x over 2 is equals to 2y over 2. But since then, we cancelled out, and it became to y is equals to 100 minus x. So to find the area, we have to write down the formula. So the formula of the area is x times y, and the y we have is the 100 minus x right here. So a is equals to x times 10 minus x. It became 100 rather. It became 100 minus x because of the y that we have here. So right after, let's distribute the x to 100 minus x. So that's why we got 100x minus x squared. So right after, let's write down as you can see, I wrote down the derivative of the area rather. So it shows there the 100 minus 2x is equals to 0, because the derivative of 100x is just simply 100, and the derivative of x squared is just 2x. So let's solve for the x, cancel out both, the 2x, and simply put the 100 below. So we can write down directly 2x, since it is 0 above that quantity. So 100 equals 2x is simply 50 equals x. So from there, we can directly determine what is the maximum value, the maximum area of a rectangle that with a perimeter of 200 feet. So by getting that, we have the area is equals to 50 times 50, and it gets 2,500 feet squared. So therefore, I conclude that the maximum area of a rectangle with a perimeter of 200 feet is 2,500 feet squared. Thank you.
Hi everyone, good day. So I am Richard Wayne Sikot Kot from grade 11 Sem 12A Charity. So we have here a optimization problem. So here, find the dimensions of a rectangle with an area 1000 square meters whose perimeter is as small as possible. So let's minimize the perimeter, and we know that the area is 1000 square meters. So let's write down all the information and let's write down what we want to find. First, I'm going to sketch a quick picture like this, a rectangle. So we call this X and Y. It doesn't matter which one you call with, and we know that the area is 1000 square meters. So that tells that the area is 1000 equals X times Y, like this. Now, let's write what we want to minimize. We minimize the perimeter of a rectangle. So the perimeter of a rectangle is 2 times X plus 2 times Y. Remember, this is X and this is also Y. So the perimeter is X plus X, which is 2X, plus Y plus Y, which is 2Y. Alright, so let's minimize this. We need to take the derivative. So before we do that, let's get this all in terms one variable, this one. So let's get all in terms of X. So, well, we know that 1000 is equals to X times Y, so that Y is equals to 1000 over X, like this. So we will plug this in for Y. So get P is equals to 2X plus 2 times 1000 over X. And so the perimeter is 2X plus 2000 over X. Now we need to take the derivative. Well, the derivative is 2 minus 2000 over X squared. That's as the derivative of this. The derivative of this. So now we need to set this equals to 0. So I have here 2 minus 200 over X squared is equals to 0. So 2 is equals to 2000 over X squared. So that's gonna give me 2x squared. 2x squared equals 2000. So x squared is equals to 1000. And so I'm gonna get x equals to plus minus square root of 1,000. So that tells us that x is equals to square root of 1,000. X is equals to 1,000. So there should x value, so you will know the dimensions. So x is equals to 1,000 meters. Now we need to know what y is. We need to know what y is. Y is equals to 1,000 over the square root of 1,000. And then, if we rationalize denominator, we're gonna get y is equals to 1,000 times the square root of 1,000 over 1,000. So let's cancel the both 1,000. So we'll have the y is equals to the square root of 1,000 meters. So we have x a square root of 1,000 meters and y the square root of 1,000 meters. So that would be all, and I thank you.